In this tape, we're going to look at setting up hypotheses. So in the research hypothesis, we're just going to make some statement about what we expect about a population parameter. So basically there will be a question that's given in the problem, and we just want to translate that into a symbolic statement about our research hypothesis. The best advice I can give you on formulating hypotheses is to put what you want to conclude in the research hypothesis. So our question is the average or population mean GPA greater than 3.0? So we want to conclude, or what we're trying to conclude is that the average, the population mean, is greater than 3.0. So H with the R, that's our research hypothesis, the population mean greater than 3.0. So the population mean greater than 2,500. So the population mean cholesterol level less than 180. Mu less than 180. Now we're going to call this, when it has a less than, one-tailed lower. You'll see why we call it that later. When we had the greater thans, that would be one-tailed upper. Population mean number of grammar errors less than 3. Mu less than 3. It's the population mean reading level of today's college text different from the 11th grade reading level. Now this is going to be a two-tailed test because we want to know if it's either higher or lower. We're not specifying a direction at the beginning. So our research hypothesis is mu not equal to 11. It's the population mean different from 15, or not equal to 15 would be another way to put that. Mu not equal to 15. Okay, next we're going to formulate the null hypothesis, which is the hypothesis that will be at the center of our sampling distribution when we compute things like p-values. Start with the research hypothesis, put the complement in the null hypothesis, and make sure that there's an equality in there. You can always state them as just mu equal. You don't have to have the less than or equal or the greater than or equal. In fact, the equal is what we're specifically going to use to compute test statistics and p-values. But as you'll see, if we reject the equality, then often in a one-tailed test we will also be, in effect, rejecting other hypotheses as well. So remember, we want to know if the GPA was greater than 3.0. Our research hypothesis was mu greater than 3.0. Now HO is mu less than or equal to 3. You can also write that as just mu equal to 3.0 in your null hypothesis. Null, or HO, null just meaning no difference, hence the equality. Remember, our research hypothesis was mu greater than 2,500. HO is either mu less than or equal to 2,500 or mu equal to 2,500. Is the population mean less than 180? So our null hypothesis will be mu greater than or equal to 180. Just the complement, making sure you have an equal sign. Of course, it could just be mu equal to 180. And again, that's what we're going to use when we actually calculate p-values and test statistics and so on. So is the population mean different from or not equal to 11 is the research hypothesis. HL will just be mu equal to 11. Again, the complement of what you have in your research hypothesis. I'm going to repeat again. Start off with your research hypothesis, put what you want to conclude there, and then just put the complement or just a strict equality in the null hypothesis.